if we ever met aliens or beings from a different civilization, what maths would they have also found? And what would we have found but they didn't?
We chop one of the sheep in half.
Yeah.
You have half the sheep, I have half the sheep.
Now where do you go?
Yeah, so I've got 5 plus...
And a half.
Oh, yeah, because you had to invent...
And are there numbers that couldn't be represented by chopping up a sheep? We're sending a lunar rover out onto the moon's surface. And there's a little bit of space in the memory if you want to write some code to run on the lunar rover.
You're going to write boobies.
Hello, Matt. Welcome to Things People Do. How are you?
I'm good. It's a pleasure to be here.
What on earth do you mean by maths and stand-up? Do you mean like you just do maths standing up, or
Yeah.
you do it sat down as well, or is it because you actually like comedy and you're a comedian now? Help me.
Yeah, it's best described as a Venn diagram because I used to be a maths teacher.
Yeah.
Category 1. Used to be a maths teacher, teaching maths to young people, and do bits of recreational level mathematics. I'm not like a industrial mathematician. I'm like a casual hobbyist in the field. But on the other side, I love doing comedy writing and stand-up and performing. And initially, like you said, they were very separate. I was teaching maths and doing stand-up. The hours don't overlap during the working day. So you can do both. It's exhausting, but for a while I did both at the same time. However, since then, the diagram has merged. So now the maths communication work I do is heavily stand-up inspired. And when I'm doing comedy stand-up, I'm still doing maths content as such.
Maths content. Joe,
Yeah.
you don't do stand-up. You like to sit down most of the time.
I do sit down.
What about maths? Because I've got a feeling today's episode is going to be slightly unusual because often the dynamic is that one of us will know slightly more about the topic than the other.
Is it?
Today, I'm so bad at maths.
Yeah, good.
I'm really, like,
You're not alone.
really.
Hey,
I'm a words
everyone's
man.
bad.
Oh, no, he is in this room. He's alone.
Oh, right. Okay.
Oh, hello,
You're
maths
very
boy.
much alone.
Go on then.
Underestimate me at your peril, Thomas.
Maybe I will.
Anyway, enough of the bollocks. I need to go back to the top of your answer when
Yep.
you said Venn diagram.
Yeah.
Fuck's that then.
Oh, great. So Venn diagram, you'll see this occasionally. It's where you have a giant circle for each category. And then if something's in both categories, you
they cross
overlap
over.
the circles and you put things in the middle.
Oh, I like that. Yeah.
It's kind of fun. And you can build them up. You can have like 3 or 4 different circles, but they get incredibly elaborate. And so Venn diagrams, which a lot of people remember from having to do at school, or you'll see them like in advertising. People love using these in like the kind of pointless diagrams. They're still open questions, things we don't know about Venn diagrams. And people are discovering new ways because it's so complicated. If you want to draw 13 circles, or you don't have to be circles, they can be any kind of shaped regions, such that there's one spot for any combination of those 13 is phenomenally complicated. Now, this is well beyond what would be useful as a diagram, but mathematicians just love to find out new things. So people are still finding new arrangements for regions in Venn diagrams, which I find amazing.
That is wild. But is it finding new arrangements or just making it up? Do you know what I mean?
Yeah.
Are they just making this up to...
You've hit on a big argument in maths. Are we inventing this stuff or are we discovering this stuff? And my rule of thumb is if we ever met aliens or beings from a different civilization, what maths would they have also found? And what would we have found but they didn't? And they have no interest in. Because if aliens show up, we can be like, hey, prime numbers. And they'd be like, prime numbers, love them. Because that's such a fundamental part of maths. And that's why I think we discover. I would err on the we discover side, but other people would err on the, nah, it's just us playing ridiculous games. It's like us solving Sudokus or something. Like we're just generating pointless things. I think we're discovering things that already existed in the universe, but in a non-tangible way.
So a Sudoku is maths.
Yes.
But is that maths just because it's numbers? Could you do Sudoku with pictures?
You could do it with letters. You could do it with emojis.
And that's still maths?
Still maths. It winds me up. People think Sudoku's maths because it's digits. And I get that's got the look of maths.
So what we're saying is maths isn't digits.
Maths is not digits.
The fucking hell. Right. Right. Just brace yourself.
What are numbers then?
What? Wow.
No, but who invented numbers?
What the fuck is that question?
That's a good question.
Okay, what are numbers and who invented numbers?
I've got another question. It's more of a statement than a question.
Go for it.
When I went to Delhi to cover the Commonwealth Games in 2010,
Show off.
I got, it's important the story. I got a tour of the local museum, and there was a big thing which basically stated that India invented the zero. And I was like, invented the zero? But a zero is nothing. How can someone invent nothing? And then it went on, this exhibit, to claim that the invention of zero, Matt, was one of the most important things that humans had ever invented.
None.
Nothing. A zero.
None, yeah.
Is a zero both nothing and something, Matt?
Oh, yeah, I'd agree. Definitely, it's really useful. And that question of what is a number, who discovered it, is still a big question. We're still finding new types of numbers, I can say very vaguely. But there was a time before when we didn't have zero, you couldn't write down like 10 because you need a zero to write 10. 1 0. So before that, you'd use symbols all the way up to 9. And instead of now using 1 and a 0, you're like, oh, I need another symbol for 10.
So if you wanted to write 100 numbers, you needed 100 different
Hundreds
numbers.
of different symbols, or you got to do a tally or something elaborate. And when zero arrived in Europe, because it was invented, discovered in India, made its way, I believe, through Italy first. And it was the accountants, it was the bookkeepers who were all like, this is amazing.
Fucking hell. I didn't think I would lose the plot this early in the record. But we haven't even fucking got onto like algebra. We've literally asked what are numbers. And I'll be honest with you, Matt, I don't want to be disrespectful, but I don't think you've actually answered.
No,
What is a number?
That's a good question, because back in, prehistory, we would use numbers to count things. So a number like 5 would be linked to there are 5 rocks.
Yeah, I've got 5 sheep.
Well, oh my God, there are 5 sheep over there.
Yeah.
And then the abstraction of, the notion of 5-ness, there are 5 rocks there are 5 sheep there. Then that was like a generalization. Humans had to realize the notion of 5 could exist separate from just counting individual objects. So now we would say the idea of, let's say, 5 is it's a combination of all the sets of things where there are 5 of them. So it's just like this notion of 5 things. But then we're like, well, what's between the whole numbers? What's between 4 and 5? And then we go, oh, wait, there's more numbers in here. If we look, there's 4.5. Who put that there?
You can't have 4.5 sheep.
You can't have 4.5 sheep.
It's
No.
not be alive.
No, because then you just go, I've got 4 plus 1. I've got 4 sheep, 1 dead one.
All right. We've got 10 sheep. Okay. You take 5. I take. Is that bad? My maths is I can't add to 10. We chop one of the sheep in half.
Yeah.
You have half the sheep. I have half the sheep.
Yeah, so I've got 5
And a
plus
half.
half. Oh, yeah, because you had to invent
Yeah.
half a number.
And then if
Exactly.
you chop your half a sheep in half,
Now where do you go?
A quarter. No.
And are there numbers that couldn't be represented by chopping up a sheep? It turns out there are. There are more numbers. We call them trans sheep numbers because they're beyond what you
we
can
don't
do.
do we?
No, we don't.
So hoping, desperately hoping.
So glad I'm not the gullible one in this episode.
But actually, the very first use of numbers like this, practically, that we have evidence of, other than we get tallies, we can find fragments of bone where humans have put notches in them. So they're obviously counting things way back into prehistory. It was the ancient Sumerians, the first people where we have like physical evidence they were counting, and they had number systems. And it seems it was basically to keep track of communal grain warehouses for brewing beer. So that's like the original source of mathematics as humans, as we know it, was from stock keeping. So to have civilization to work, or maybe vice versa, you need to be able to brew beer on a decent scale. And so
Yes,
that's where maths, as far as we're aware, came out of.
So maths came from a bunch of pissheads.
Or vice versa.
You clearly love maths. Like
fan.
your face lights up talking about this subject, even with the ridiculous questions you've already been offered. But where did that start? You've mentioned you're a teacher, but were you a kid, and were you one of those kids that actually, as opposed to the majority of kids I knew growing up, we were like, oh, fucking hell, maths.
Yeah.
What the fuck's this for? What? Just because I need to count whether someone's given me the right change from the shop, which you don't have to do now because no one seems to take cash. But did you have a different mindset as a child?
Yeah, what's interesting about mathematics is it's easy to convince yourself you're not good at it, and it's easy to not enjoy it at school. And the moment you think, oh, I'm not good at maths, or I struggle with it, or you don't enjoy it, which is fair enough, if you get behind, it just gets worse, because now you understand even less next time, and it spirals. So particularly when you're coming out of primary school into secondary school is the sweet spot for students just convincing themselves they hate it, they're useless at it. I had the advantage of my dad was an accountant. My mum worked as a librarian. So as a kid, they were like giving me maths problems to do and convincing me this was fun before I went to school. So I showed up already convinced, hey, maths is great. And it meant, because everyone finds maths difficult. That's the distinguishing thing. It's not like people who love maths find it easy. They like the fact it's difficult and a challenge and rewarding.
Yeah.
So don't think, I'm not good at maths because I find it difficult. That's literally everyone. Apart from maybe like 5 genius savants who just showed up and somehow live and breathe maths. Everyone else, it's such a challenge to learn maths. But if you've got the can-do attitude of, it's okay to get things wrong, I want to give it a go, I want to learn it, and it's not necessarily just for counting my change or things that are useful, although that is handy, that just that momentum makes all the difference learning and enjoying maths.
Did you have a calculator at school, Joe?
Yeah.
Did you use it A, more for doing sums, or B, for writing shell oil or boobies?
Shell oil?
Hmm.
I don't know that one.
Yeah.
No, boobies was always a go-to, but I'd always forget how to do it, so I'd ask a mate. But
Okay.
I actually
5, 1,
3. Look at that.
8,
That's ingrained deep, isn't it?
008.
see her boobs. See her boob.
You got to
Oh,
turn
you
the
turn it
calculator
upside
upside
down.
down. That's the
Okay. Yeah, I really enjoyed my calculator because it had things like, well, aside from numbers and the digits, it had AC. What's AC?
The classic. Get rid.
What does that mean?
people refer to it as all clear.
Oh.
So you're clearing everything.
Okay, all clear. It had C.
Yep, regular clear.
Okay, this,
Not all.
these are the deepest questions I've come up with.
I mean, the classic, you just mash both of them a couple times
And it goes.
to make sure
Yeah.
you're, yeah.
I actually used to enjoy because I had the one, you know, the classic grey, and you, it was solar powered.
Yeah, that
Just
was
cover
good.
it
That was
and it would go. Yeah, I enjoyed that. But I remember cos, sin, and tan.
Yeah.
And I remember them because every time I looked at my calculator, I went, what the fuck is the point of those? And not once in all of my education did I press those buttons.
Not even to see what they did.
No, I was like, that's just nonsense. I'm not outputting. But now that I'm a 34-year-old grown adult and I've got an expert in maths right in front of me, Matt, please, can you help me? What is cos, sin, and tan?
Yeah. Cos, sine, and tan.
Oh, I've said it wrong. Brilliant.
Well, they're always abbreviated to 3 letters, but for some reason we keep sine pronounced as sine. They're the trigonomic functions. They're another way of measuring the size of an angle. So I do a bit of cycling, and occasionally you'll see a sign coming up, like a physical sign, not a sign. And it says like gradients 21%.
Yep.
They're telling you the angle of the road, but they're giving it to you as a percentage, which is actually the tangent. That's the tan of the angle of the road coming up.
Tan for tangent.
Yeah.
Breakthrough for me.
Oh, yeah, because you love cycling as well, don't you?
Yeah.
This is huge.
Yeah.
Oh, what a day.
I just love the fact road signs use the tan of the angle. And everyone's like, yep, they're just fine with that because it's just a percentage or a number on a sign.
This is one which baffles me when I'm cycling.
Yep.
Matt. If you see a sign that says 20%,
Yep.
but that's not the same as 1 in 5, even though 20 is a fifth of 100.
Well, it depends over what distance it is. Like, have they averaged it, or is there just like one spot on that road that's going to be
A wall.
20%? Yeah.
On those signs, would there ever be 100% and would it just be vertical?
It would actually be a 45-degree road because it means for every mile you go forward, you've gone up a mile. It's 100%. Whatever you go across, you go up.
This is going to be one of those
This is-
episodes, Joe, where our minds are blown.
This is fun.
Every single
This
minute.
is you've like within the first 5-10 minutes of this chat, you're starting to make maths 100 times, 100% more fun
You've hit a
Then-
wall, is what
than
you're saying.
Mr. Brown did.
Yeah,
I'm sorry, Mr. Brown really got it, and I felt bad because I'm sure he loved maths as much as you did, Matt. But he had a class that was unruly
Yeah.
and flicked ink cartridges on his back, on his blue pen, on his blue shirt, whilst he was writing sums. And I feel bad. And I'd like to say, if you're still with us, Mr. Brown, and for some reason you're listening to this podcast about maths with Matt Parker, then I'm sorry for flicking ink cartridges on your back. It's off my chest now. Thank you. So were you like a grade A math student then? You'd already had you get maths, further maths. Did you? So you must have had pre-maths.
Yeah,
so your parents giving you.
Yeah, I got the rolling start of pre-maths.
Yeah.
Then I really enjoyed it at school. So it meant I got good grades because it was kind of fun to do. And I didn't mind the fact you have to really plug away at it. I hit the wall once I got to university because there's always a point in everyone's maths career where you can be like, if you like maths, you're good, quote unquote good at maths. You're like, oh, this is great. And you kind of get used to being the person who's good at maths. And at some point you hit a wall, like a room of people, and you're like, oh, they're all better at maths than me. And that, for me, I got to university, I'm like, here's the people who are good at maths. And that's a real daunting experience. But functionally, it doesn't make a big difference because it's always hard work. You're always chipping away at it. And there's always, the issue is that you never get to the end of maths. Everyone, they get to a point where the next bit of maths is super difficult and beyond them. So we all just stop somewhere different before we hit the maths that we're not yet able to do.
I found, Joe, at university that the math students were the ones whose brains were so obviously much bigger than mine. That
Physically?
Just, it was intimidating. I remember, Joe, there was a table tennis team, and I quite liked a bit of table tennis. And I got there, and there were kids who were just smashing the ball past you. For some reason, they all did maths.
Is there any relevance to sport and maths?
Correlation between
maybe they were doing
table tennis trajectories.
Yes.
I mean, pool, I'd understand because that's all angles. Yeah. I've tried to apply my maths ability to sport, and it's been unsuccessful every time.
What examples can you give us?
I definitely tried pool. So I played a professional pool player. It's in the States, in Brooklyn. We had a team. We had 2 pool players and 2 mathematicians. And I'm like, you set up, we're not going to do a full game, set up one of your like training drills. And they put the balls, you got to hit it off here, hit it off there and sink this one. And we're like, piece of cake. We're drawing diagrams. We're working out the exact angle. And then we're way off because they're like, oh yeah, you didn't factor in like the humidity in the room changes. But it turns out the maths concepts we had are what they're doing, but they just know how to factor in the messiness of the real world.
This has got me thinking now, Joe, about all the different things you do in sport, which are fundamentally maths. So let's say we had Stuart Broad, didn't we, on the pod recently. If you are Joss Butler, keeping wicket to Stuart Broad, and the batter edges it, then you are fundamentally diving and you have to calculate the rate the ball is travelling. It's moving on up and down as well. It might be moving side to side. You have to intercept it with your hand at exactly the right point, which now I'm thinking about it, Matt, sounds like the most, almost like landing on the moon style maths. And people would just do it, just taking a catch.
Yeah, it's interesting. The maths our brains can do intuitively and the maths that it can't. And because we've evolved to throw and catch things, our brains are just, they can see the beginning of the movement of an object and our brain's like, oh, it's going to, we don't even like, we're not aware of it doing anything. We just know it's going to be over there. And I find that absolutely phenomenal. And then the other side is the maths we're not good at doing. That's when you get results like when stats took over baseball. Well, stats have always been in baseball, but when people realized, oh, we can use mathematics to locate players who will have a bigger impact on the team.
The Moneyball system.
The Moneyball system. Then we expect.
The stats.
Yeah. So I went into Liverpool Football Club because they've got a big sports analytics team, as you can imagine. And they're basically tracking every football player in the world. Across every league they can get data for, they're tracking everyone. Because their big impact in terms of maths and analytics impacting their team is scouting and recruitment. Because if they can spot an up-and-coming incredible player, and they may watch a player through several different teams they're bouncing around, but if they know the right point to get that player, that'll have a big impact on their team in terms of the value of what it costs to get the player versus the impact on it. And there's no way, because obviously back in the day, people would smoke a cigar and say, that kid, they got potential. Whereas now they got a big spreadsheet and they're like, this person in this country's got potential and they're worth pursuing.
Yeah, I mean, you've brought up Liverpool, but and seeing as you've brought up football, it would be remiss of me not to back up the mighty Seagulls and Tony Bloom and their recruitment policy and this sort of mythical algorithm that he has from his, I think it was, I want to say gambling.
Yeah, he had a background in sports betting. And then they've created this algorithm that they somehow nail finding these gems, how you've just described.
and they bring them in, they buy them for like $500,000 or $1 million. They spend a year or two there, and 9 times out of 10, I just use maths there, didn't I?
Huh?
Or 90ths out of 100.
Yeah.
Does that work? Yeah, it's the same thing, mate. 90% of the time, they're a gem and they sell them on for like triple or quadruple the money. I just didn't feel comfortable you mentioning Liverpool and me not coming back at you with the mighty seagulls.
The only reason I would go Liverpool is I've been trying to get the government to change the street signs for a football stadium for a very long time.
Why?
Because the picture of a football on the UK street signs is incorrect.
Right.
Yeah, football. So the light-coloured hexagons, I got no issues with that. That's great. The dark-coloured panels should be pentagons with 5 sides. And they've depicted them here as hexagons with 6 sides, which you might think is not a big difference. 5 sides, 6 sides, who's complaining?
Yeah.
The reason it winds me up is mathematically it's impossible to make a football out of only hexagons. So that is mathematically impossible.
Oh, hang on. I'm challenging you on this.
Yeah.
If this is like legit and you're going to the government, how's it mathematically impossible when that clearly looks like a football? The circle is circle.
Yep.
And it fits all the stuff in. Doesn't matter what sides, how many sides those shapes have.
You're actually correct. So this is a 2D flat picture of a ball, and hexagons work great in 2D. That's why they've used them for the sign.
Okay.
Because you can fit them together nice and neatly. In 3D, if you actually cut them out of that sign and tried to stitch them together into a ball and do the other side, it would never line up. You'd never be able to close that ball and finish stitching it together.
Okay.
And
that really winds you up.
Really winds me up.
Yeah.
I had a parliamentary petition. we got over 20,000 signatures. It's
off.
a big issue, you know. We got to... and the government wrote to me and said, because they have to give a response. I got enough signatures, they had to respond.
Yeah.
They responded and said no.
Oh.
Which is not, we don't
How
care.
many signatures do you need?
Well, more than 20,000, it turns out.
Right. Okay. Right. This is calling out to all the things people do, listeners. Let's join the petition with Matt Parker to change. What would you change it to?
I don't mind. As long as it's accurate.
Okay. What
that's
if
what we're asking
what
for?
if that's
Just
just
asking for accuracy.
if that's just
pentagons,
all brown? Oh, then if it's all brown, you can't see it.
Yeah.
If it's all white, are you happy with that?
It doesn't look
No, it's
round
not
then.
like a football.
Right. So you want all of these signs changed to like a 3D
Officially, only future signs.
Well, listen,
as they put them in.
I think you've been very generous here. You're meeting them.
I'm trying to meet them in the middle.
Yeah,
I
you
understand the expense of changing the old signs may not be warranted for my mild mathematical concern.
But going forward,
why can't we? Other countries have correct-looking footballs.
Let's make the world a better
With the
place.
laughing stock.
Yeah, fair.
So I got someone to design an actual custom football for me, which isn't all hexagons, but if you look at it from one specific angle, it looks like this. And so I took it into Liverpool so they could have a look at it, and they said there is no way the Premier League would ever go near that ball.
Oh, they wouldn't play with it?
No, because as it rotates, it changes how it looks. Like, it's an absolute nightmare.
Spice it up a little bit.
Spice it up.
That's what I said.
Each team can opt to play with that ball for 5 minutes of any given 90 minutes.
Baller League. The new Sky Sports YouTubers Baller League.
Right, they might be up for it.
They'll be up for that. We've got to start somewhere. We've got to get out
Start at the bottom.
The Lions Tour is here.
That's right, Ben. The British and Irish Lions Tour is underway, and it's a super team constructed of the best players from England, Scotland, Wales and Ireland.
And our podcast for the love of rugby will be covering all the action as they tour Australia.
We'll be joined by players in the squad,
bring you on the whistle insight,
and the best Lions stories from tours gone by.
Just search for the love of rugby and we'll be your podcast for a cracking summer of rugby.
With him, Ben Youngs.
And him, Dan Cole.
See you there.
Right, let's rewind. Let's go back to Matt, the maths teacher, and let's pretend that I'm thick. Okay, there wasn't many objections from either of you with pretending that I'm thick. Fine.
Joe, you're not thick.
Thank you, Tom.
Yeah.
Still get that same look.
This is my neutral resting face.
Okay. Algebra.
Yep.
As layman as possible.
Yep.
Could you explain to me, Joe the child, the thick child, who's struggling with the challenge of maths, algebra, correct me if I'm wrong. A equals 1, B equals 3. So if the sum reads A plus B equals C, which is 4,
Yep. Yeah.
have I nailed algebra?
I mean, you've done my job for me. Basically, the beauty of algebra is if you had a situation like that where something is one, let's say you're building a building and the door, the base of the door is 1 meter high, but then you've got to put this 3 meter thing on top of it. And so you know the total is going to be 4. You might, instead of writing down, oh, this part of the building is going to be 1 and 3, total 4, you might say, well, it's going to be A, whatever this bed is, plus B, whatever that bed is, and that's going to give us C over here. Because then that factors into a different part of the planning process. And the beauty of algebra, instead of just using numbers for one specific value, if you put it in terms of letters that represent numbers, you can then see what happens if you vary what each thing means while keeping that relationship whole. So if you want to design a very complicated building or system, it's handy to know, well, these two numbers have to add to whatever that number over there is, but if we vary them across the plan, that relationship has to stay there. So algebra is about going from specific numbers and sums to relationships and the way numbers interact, which gives you a lot more flexibility.
Okay, why is maths at school boring?
Well, it's partly because it's easy to teach maths badly, because it takes a bit of motivation and creativity, which is why I love teaching it. You got to be on your game to convince teenagers to pay attention and learn maths, because they got a lot going on in their lives. And as you say, they'd rather be doing something they find easier or more fun. So you've got to really put a lot of effort in. It's also a bit boring because, like sport, you got to learn the fundamentals and skills before you can be any good in a game. And so maths, a lot of it is like, why do I have to do this worksheet of 10 problems? And like, well, you're practicing one skill. And what's a shame is at school, it's easy to over-focus on honing the skills without ever playing a game. Because why learn all these maths techniques if you never get to do anything interesting with them? And we tend to stop short of doing that. So I think, and then this comes down to, how much time teachers have and flexibility and all this stuff. But if students had more time to apply and use their math skills, it'd be a lot more fun to learn, to do the boring bits, like the practice, to get the hang of it.
That tells me, Joe, we need to do some games. Yeah, we need to gamify this maths chat.
Okay.
The first bit of game we're going to have has been lined up, I believe, by producer Vicky, who is claiming that she has lined up a things people do Venn diagram, which when I click my fingers is going to appear on the screen behind me.
Right.
Be honest, Vicky, I was hoping for better. Than that.
Right. Matt, is this legit a Venn diagram?
So in the Tom circle,
Okay.
things Tom does or enjoys or is focused on. And then likewise in the Joe circle, you go everything that you do or
Wow.
enjoy or are focused on.
We're really that simple, are we?
Yeah.
Cheers, Vic.
Anyway, I don't want to do any further psychological analysis of the Venn diagram, but that's
Yeah, I mean, it is a Venn diagram. That's what
it's
we can
definitely
say.
100% a Venn diagram. Yeah.
I know, but that has actually made me I've enjoyed that. That was fun.
Isn't that pleasing?
And that's maths.
That's maths.
Isn't it? I mean, I'm still not sure how the fuck it is maths.
Now that you're both enjoying this diagram,
Yeah.
you could put this diagram in the middle of that diagram as a
This is
Right.
Inception.
Yeah.
Hang on.
Inception level
Does
shit.
that then mean we could then put a picture of that Venn diagram?
Yeah, if you really
in
enjoyed
the
how
middle of
funny it
that.
was putting the diagram in the diagram, you put the whole thing again.
So it's like when you put two mirrors next to each other and then it just
Yeah.
Is that maths?
That's 100%.
Is it?
Putting two mirrors and it fucking off to infinity
Well,
is maths.
being able to understand how that works is maths. Absolutely.
Are you able to try and help me understand?
Oh,
how
I
that's
love that
maths?
stuff so much. There's a thing called the Droste Effect, which is where you
Oh,
put
yeah.
a thing inside a thing.
Mm.
It's named...
Sorry, you put.
Okay, that's the worst sentence that I could use to describe that. But there was a hot chocolate brand, I think in the Netherlands, called Droste. And on the packet is someone holding a plate with a packet of the hot chocolate that they're on. So they're also on the packet, which I just find that stuff hilarious. And so mathematically, you can analyze how all that works. And so some friends of mine did some research into this and some programming. So I, for one show, had a one of these 360 cameras live on stage, but I could then take the feed from it and put it onto a screen on stage to feed it back in again. So we could have this recursive effect happening live because we did all the coding to kind of make it work as we were on there. I find that stuff super interesting. And it touches on, there's a whole area of fractals and these sorts of recursive self-similar structures. And I think where people get confused about the why is that maths is numbers are such a prominent part of maths that everyone's like, well, that's maths, it's the numbers. Maths is actually just the study of patterns, and trying to solve problems in terms of what's the logic behind that? What is the pattern that we're seeing glimpses of here? And numbers are just a really good manifestation of that. That's just a really nice example of a whole lot of patterns, and they ended up being really useful. So numbers are incredibly handy just in society. Shapes come a close second because geometry,
isosceles triangles,
all that,
or
the other ones,
equatorial triangles,
or right-angled triangles,
right-angle triangle, equilateral triangle,
a rhomboid.
A rhomboid. There are you. One more side, but we're okay with that.
And a polygon.
There you go.
And an octagon, septagon, megatron, teratron.
Have you been working out on your rhomboids? Because they're looking quite...
What's the rhomboid? Is that my neck?
You got traps, trapezoids.
Trapezius triangle. Is that a triangle?
Trapezium's its own thing.
What's that
It
thing?
doesn't need no
What's
triangle.
that thing where you've got two sides that never fucking meet if they carried on?
Yeah, parallel lines.
Oh yeah.
Or a parallelogram is if you then just cut it off and turn it into a shape.
And what's the one where you have a shape that start not touching and then they touch?
I mean, the easiest version is the triangle, but you get this whole set of like pyramids or cones that all do the same thing in 3D.
Like a cylindrical tube.
Cylinder, you had that.
I'm just
yeah.
cylinder.
Yeah.
That's it. A sphere.
But naming these shapes is fun.
I'm just trying to recall all the stuff that I've learned and then go, well, I would mock it going,
Yeah.
oh, what the why am I learning this shit?
Trapezoid.
But actually, it's important to know that, because someone's going to ask, oh, what's that over there? And you go, oh, that's a camera. It's of a cylindrical shape.
Well, the camera, so a friend of mine who does VFX will talk about the camera frustum, which is if you take a pyramid and cut the top off, the top bit's just a smaller pyramid.
Yeah.
The bottom bit is now what we call a frustum. And that's the shape that us as the image and the sensor and the camera make as in terms of like the mass of how we go from being here and then being an image on the sensor.
Fuck.
So these ridiculous shapes are then the weirdest places they'll pop up and be useful. But maths is not those examples of patterns. Maths is just the idea of looking into fun patterns.
I think we should do some more games here, Joe.
Well-
when you are helping the kids with their maths homework,
Chips and peas.
tell me more.
Well, I actually struggled to begin with the kids' maths homework because they come home using techniques that I didn't know, that I wasn't taught. So when they actually end up teaching me, and I'm like, what do you mean chips and peas? And they're like, well, a chip is 10
Okay.
and peas are single.
Oh, okay. Yeah.
I was like, that just seems really lazy. Why don't you just write 20 peas or draw? They had to draw them.
Is that ratio of peas to chips the sort of ratio you would like to see on your plate?
I'm not very good at helping the kids with maths.
In that case, Matt, do you think if Joe gives the age of his children, you could try him with a maths question appropriate to that age of child and Joe can see if he can answer it?
Yeah.
Oh, fuck.
So Jasper is now 10.
He's 11 going into 12 secondary school.
Okay. Jasper is 11. A question for Jasper and thus
Oh, he's
Joe.
coming up into high school years. Yeah, the wonderful thing about going from primary to secondary is you start to generalize stuff and find patterns. So this wouldn't be something you could do here and now.
Bet you can.
What I love for students at that age is when you look at the 9 times table, you look at
81.
the answers, exactly. If you add the digits of any answer in the 9 times table,
Fuck off, Matt. Fuck
It's
off,
9.
Matt. I did this the other night.
Here we go.
My daughter was there doing her times tables, and she was like, I was like, what are you doing? She said, I've got to do the 9 times tables. And I was like, right, I know this one. I remember this one. I said, what's 9 times 9? And she's like, it's 81.
Yeah.
What's 6 times 9? 54? Is it 54? Yeah, thank you. And so I was doing that with her, and then I was like, up until you get to 10 times 9. No, 11. Yeah, up until you get to 10 times 9. This is exactly how the conversation went, Matt. Like
this is perfect.
So this is how shit it was. I went, all the answers
This is a dream conversation for
add
me.
up to 9.
Yeah.
And she goes, what do you mean? I was like, well, what's
I love how you're explaining this to Matt.
what's 6 and 3 added
It's like
together?
I'm there. It's
And she
great.
goes,
Yeah.
9. I went, exactly. So you know that's the answer. She's like, answer to what? That hasn't. All I know is that you're adding up these numbers that add up to 9, but it's not giving me a signal of what 4 times 9 is. And I went, yeah, you're right, Maggie.
right.
You're right. I'll just do the answers for you.
That's the exact step you'd want to see from doing times table, is spotting the patterns. in it.
Patterns.
I was terrible at times tables when I was at school because it was just memorizing things.
What about
Not
12
literally.
times 9? What's that?
12 times 9 is going to be
108?
That
No.
feels about right. Yeah, 108.
108.
Yeah.
Oh, it starts
Back to
again.
9 again.
I can do that. Add all those numbers. 1 plus 0 plus 8. What'd you get? 9. Voila.
Yeah. But if you get your calculator and multiply any number by 9 and then add the digits, if it's not 9, add the digits. If that's not 9, add the digits. And eventually it'll be 9. Just for bigger numbers, it takes more iterations together.
That's so. I can't wait to go home tonight. Even if she hasn't got maths homework, I'm saying we'll do it.
Sit down.
Tonight.
Yeah.
Is 9 your favourite times table?
No, probably 10.
Yeah. 10's a clash.
10's a banger.
Yeah. 11's nice though, isn't it? Because once you realise
It's
11.
only up to a point. Like 11 times 11.
But 11 feels like it should be more complicated because 9 is a horror.
2's quite nice.
2's lovely.
4, 6, 8.
Isn't
8's tricky. 7's
We all
tricky.
agree 7's the worst.
Yeah, 7's really tricky. The only one of 7 I really know is 7 times 7. And
that's your banker? 'cause
and
you
that's
can move up or
always
down from
49.
there, can't
It's
you?
always
Yeah.
49. 8 times 7, not a clue.
No idea.
4 times 7, it's 28.
Yeah. How did you work that out? How did you get to 28?
I went 7 add 7 is 14.
Yeah.
And then 14 add 14 is 28.
Yeah. That's
Is that a long way round?
That's what I do. I have skipped the first step. I'm like, I know double 7's 14, so I just double that in my head. So that's how I get. So I do the same process, but start one rung up. That's the same idea.
And why in the fuck is there a minus set of numbers? That doesn't make sense. How do you have less numbers than actual numbers?
I'm with you on that one. You've already got nothing, so how
You
can
can't
you
have
go
less
beyond
than nothing.
No, you can't go beyond nothing.
What's less than nothing?
Yeah, you're right. The same deal as like when 0 showed up, everyone's like, well, maybe there are more numbers
Yeah.
in the same direction.
But that's really, I would say,
Yep.
I would argue hard that when they said there's more numbers, they've just taken the numbers they've already got and just
And
put,
put the
a
negative
dash
sign in front of it. Yeah, no,
next
fair
to
enough.
it.
When you say you'd argue that hard, is that something that people would dispute?
I go, it's fucking lazy. Oi.
So you want
Maths
different
fuckers.
numbers rather than a minus?
Yeah, it should be like,
Actually, yeah.
it should be like
What would you call it? What would you call a minus
But
one?
do you want
rather than
a
minus
better
one?
symbol or just
a better
more-
symbol.
Yeah, okay.
Like
right,
to
yeah.
really differentiate. I don't think what's it, negative sign?
Yeah.
I don't think that
Little dash thing.
that
It's not, it's
dash.
not working.
is enough. Do you
What's
know?
handy about it is we kind of use the obvious ones first, because now to signify different types of numbers, we got to put like a hat on them or underline them or put an apostrophe next to them. So that there's now all these different ways you decorate numbers to indicate subtle changes.
I've got some really tough questions that I want to put to you, actually, Matt, about this.
I'm ready.
I'll start off with why, if you times a minus number by a minus number, do you get a positive number?
Yeah.
I mean, the lazy answer is because if it's like what happens if you take away a whole? Because if you're removing something that was already removed, what are you're filling it back in again. So so that's
Whoa. So if I let, and I'm sorry for interrupting, Matt, but this is the classic way these things are explained to people like me and maybe Joe who have struggled with maths in the past. So there's a cake in front of Joe.
Yeah.
Okay. And I'm not giving Joe 3 pieces of that cake.
Why aren't you giving me the 3 pieces?
That doesn't matter. So I've taken 3 of these pieces from Joe. So Joe doesn't have 3 pieces.
Yep.
I've then taken 3 more pieces from Joe.
So I've got no pieces.
But using that minus times minus, haven't you suddenly got...
No, if you took away the missing, like if someone
Oh.
served,
So I've taken the 3 pieces
Yeah.
and then I've taken them back.
yeah.
Oh.
If you took away the missing pieces, so someone gave you a cake and there's a piece missing, you're like, hey, there's a piece missing. So
Where
it's
the
like,
fuck's my piece?
I'll get rid of that empty piece for you.
By bringing
to take
a piece
away
back.
a lack of a piece, you've got to add a whole piece.
This is good news, Joe, because you've gone from having no piece of cake to 6, the entire cake.
And can I have that?
You can have your cake.
You're not going to take
any
any more away.
I wouldn't mind 1 slice, and it'd probably be polite to offer our guest a slice. It would still leave you with 4 slices.
I just love, after all the zero slander, you got very upset at the notion of zero cake. Like, you understood zero in that moment.
Okay. So you answered that one really well. Thank you. Square root of 4.
Yeah.
What is it?
-2. So
What the fuck is a square root?
roots are interesting because it makes sense if you're using numbers practically to square them. So if you wanted to work out, so in the studio here, there's a lot of squares on the wall. If you wanted to work out how many it takes to cover the wall, you'd count how many across, how many up, multiply them together. Or if it was a square, well, it would be the same number twice. So multiplying a number by itself to get an area happens a lot. But what if you started with the area and wanted to go back to how long the side must be? Well, to undo a square where you multiply something by itself, the square root is just the reverse of that. So if you...
So the root cause
The root cause
that
of the square.
becoming a square.
Yep. And so if you said the area of this square table is 4, what's the square root of 4? The actual answer is 2, because 2 times 2 would give you 4. The reason I said -2 is I think it's very funny that there are other less useful answers to the same question, because as we just said, a negative times a negative is a positive. So technically, -2 times -2 still gives you 4, even though it's not the helpful answer you actually want.
Do you think negative numbers get a bad rap?
I do. I think it might be the naming.
Yeah.
Yeah.
Why don't we come up with a better
Optimistic
negative?
numbers or something.
Yeah.
Yeah. Can
Reverse
do
numbers.
Reverse numbers. I like reverse numbers.
Okay. Has there ever been anything in maths that, like an equation or something, a pattern that you've discovered or or learned that's actually changed your outlook in life? Do you know, like relating to that?
Yeah. There is a thing called the optimal stopping problem.
Okay.
And this is the idea that, let's say let's say you're dating people and you want to find a life partner. The first person you date, you have no idea what it's like to be in a relationship, what to expect from a relationship. But the question is, do you want to end up committing to the very first person, or do you think you don't understand what's out there yet? Or let's say you're, buying a house. The first house you view, you're like, well, this seems pretty good, but I have no idea what the general market's like. Optimal stopping problem is, how many experiences or viewing or data should you get to understand what's out there and then decide, I'm going to get the next best one that I come across because I think I understand it. Because if you wait too long, you're going to miss up loads of, maybe the first one was the best one. You're going to miss a bunch of opportunities. It turns out, mathematically speaking, if you take the square root of the possible number of things you're prepared to experience or view, that's the optimal point to stop investigating and start choosing.
We need to go into this more, Joe.
Yeah.
Okay, let's use that example you've given us there, Matt, of hunting for a house.
Yes.
So when you say the maximum number you're prepared to see, this is sort of the number you can cope with mentally of houses you can remember or practically you can get round to.
Just practically. You're like, look, if I see 100 houses, it's going to take too long. It's too enough. I can't do more than that.
Okay. Joe, when you bought your current house, how many houses did you look at? For the purpose of this exercise, we'll include ones you looked at online as well as in person.
In person, we looked at 4.
Yeah.
Online, that's hard to. It was just fucking
Yeah.
on Rightmove, so it's constant. So I don't know. Let's say in person 4, in total 54.
Yeah, but that's a different. The number you're prepared to scroll past total is a bigger number than the
Okay,
number
we'll
you're
go with
prepared
the
to visit.
in-person
Yeah.
version
Yeah.
then. Yeah, okay,
Yeah.
just 4 then.
So that means if this 4 is the square root of like 16 or so, so that's saying maybe if you had 20 houses in you, that's about the
So
correct number.
So what we should have done was go and look at
Yeah.
16 to 20 houses
well-
before deciding, because that's the optimal
It's
stopping
normal.
number.
The optimal stopping, if it's you think you could view up to 100 houses before you buy, is to just see 10 without making any decisions, and then pick the next best one you come across, understanding what you've
So
seen
you
from
wouldn't
the
pick
ones
the
so
best
far.
of the 10 you'd seen.
No, you want to kind of burn 10 to get a sense of what's out there. Now, what I think is interesting is, on one hand, humans, we always stop too soon. In experiments, humans tend to stop too quickly, or we end up never stopping. We become obsessed with the hunt, and there's something else out there. But also, it's not like a hard and fast rule. I think it's just for me, the reason it was my Zen moment was by taking me and my emotions out of these situations, just knowing, oh, this is not necessarily true of any one specific example, but on average across all examples, this is the optimal point. And so just having that as, a rule of maths, it just helped me to make sure I was thinking through these sorts of situations better. It's interesting, a bit of maths like that just changed slightly the way I conceptually go about living my life.
Matt, tell us about the adventures that you have on YouTube, because you do some pretty remarkable things.
No, wild. It's wild.
I love YouTube. It's so much fun. I did recently get stung by a bullet ant in the Amazon because I got an email from some researchers, because a lot of scientists watch my channel. I got an email saying, hey, we do research primates and ecology in the Amazon rainforest. Do you want to come out and we'll show you some of our research? And I'm like, absolutely. And they're like, oh, one of the things is insect sting pain. They're like, if you want, this is not normally offered. You can't just show up and say, I'd like the bullet ant experience, please.
How big is this bullet ant?
About, I'd say 2 or
it's-
3, like 3 centimeters maybe,
Oh,
like an
okay.
inch.
Sort of size of a bullet.
Yeah.
Yeah.
Oh,
I've gambled that.
This
I didn't know if
whole
it was true.
this whole
I didn't even know if that was
episode
true.
is just discovering new things. And thank you, Tom. And it would have been nice if you maybe dressed it up in a less patronising way.
No, that's
Thank
where the
you.
name doesn't come from. So
Fuck you, Matt.
they're so. But thing is, the YouTuber side of me is like, that's great content, getting stung by a bullet ant. And mathematically, it's interesting because how do you assign an objective number to pain? And so that intrigued me.
So you just say how? What do you mean? How do you assign an objective number to
Yeah,
pain? You
like
just go, what's the score out of 10?
Yeah, but how do you know that the pain you're
Well,
experiencing?
10 is the worst pain you've ever had. 1 is no pain.
Well, that would depend on your previous pain experience, where your 10's going to be.
Yeah. Let's say the worst thing that's ever happened to you is you cut your finger. If you then had a testicle torsion, have you had a testicle torsion?
What is that?
Big Al had one, and he said it was the most painful thing that it's possible for a man.
Oh,
to
your
do.
nut. You twist your nuts.
It's a nut twist.
Oh yeah, no, I haven't. No.
So that 10 would be bigger than the 10 you'd previously experienced.
Well, that's subjective.
Exactly.
Yeah.
That's what I mean.
Yeah, no, it's objective, but if people are researching the evolution of venom, because you can measure scientifically how toxic it is in terms of being fatal,
Yeah.
but pain is such a whole different, more complex game. It's difficult to study and investigate how venoms evolved if you haven't got a way to measure the pain impact of these venoms. So I got a bit overexcited. I said, hey, before I get stung by the bullet ant, could I first of all be stung by like a calibration wasp?
Yeah.
And
What do they look like?
we all agree that's like a single unit of insect pain.
Okay.
And so they found me some wasps. There's a couple of us did
Calibration
it.
wasps.
Yeah, calibration
Yeah.
wasps. Then we had a slightly more painful ant. And then we had a terrifying wasp. And then the bullet ant. And the bullet ant hurts, but then just stays there for like 8 hours.
Oh.
What?
No change.
What? It's a very hard question to answer. Maybe I was going to say what level of pain, because it's the level of pain of a bullet ant.
Yeah,
but,
yeah.
Like, what's a household level of pain that the bullet ant?
You know what? It's the most painful insect on Earth. But compared to other things you can do, it's not like ball torsion or whatever we were discussing a second
Yeah.
ago. It was that combination of bruise and rash at the same time. That's
Localized
what it
or-
felt. Localized, yeah. So I got stung on my left forearm, and just from elbow to hand, it was weirdly spread out. It just felt like I had a cycle crash, and it had that real intense pain, but it didn't subside the way you'd expect pain to go off over time, because it's venom causing it. So I had a lot of fun, and it was a ridiculous mass thing to do. And at the moment, the next YouTube project is calculating pi on the moon.
Right. 2 questions.
Yes.
What the fuck is pi?
Yeah. Okay. Yeah.
And what do you mean on the moon? Like you're going to go on the moon to work what pi is, or
The
pi
second
of
one,
the moon?
No, the second one I can answer easier. Some
Okay.
engineers got in touch and said, we're sending a lunar rover out onto the moon's surface. And there's a little bit of space in the memory if you want to write some code to run on the lunar rover. And I was like, yes, please.
You're going to write boobies.
Just grow up.
Well,
Just grow up.
Boobies on the moon.
Just use that optimal stopping point. Yeah. And apply it to your life sometimes. Thank you.
I mean, I'm not here to market this, but we are crowdfunding it, and people are submitting their names or bits of text to go up on the rover to be part of the calculation.
We've got to do it.
So there's probably a boobies in there somewhere.
We've
What?
got to do it.
How much?
Surely we can put boobies, things people do's boobies
Yeah.
in that code.
Could we?
I'll give
Mates
you
rates?
one free ride.
Really?
Yeah.
Wow.
Put you on the rover, send you up
Wow.
there.
We're going to the moon.
Well, we're not.
Fly me to the moon.
Okay, now I can't stop. I can't resist this. Let me play among the stars.
Writing boobies on a calculator.
Maths.
Bound for Mars.
No, it's the moon.
Mm.
Fucking twat. Sorry. Right, what's this called then? What's this project called?
Moon pie.
Moon pie.
Moon pie.
Moonpie.com.
Wow, that's such a early 2000s.
Yeah. That's,
Well, I got pi.space as the website, which I'm unduly proud of.
okay.
And pi, to come back to your first question,
Yeah.
a lot of people will come across pi at school because it's the ratio of the distance around a circle, and I'm pointing at the mug here, versus across the circle. But the reason I love pi so much is that's only one of so many different places it shows up. It's like the mascot for maths, where you'd be doing some unrelated maths and pi will kind of drop out of the answer, which I find absolutely incredible.
So pi existed before we knew about pi.
Absolutely. I
Well,
would say
it was invented by Pythagoras, wasn't it? And we've somehow shortened it to PI instead of PY, which baffles me.
Matt, when I was at school, I really enjoyed economics, and I would have loved to have done economics at university, but my maths wasn't good enough.
yeah.
So I couldn't. So I downgraded, and I think that's the right word, to geography. Then I got there and I found that geography still required
More maths, yeah.
So I was given a book called Statistics Without Tears to get me through it.
Ah.
And it turned out not to be true.
Well, yeah,
There
it was
were
a
lots
lie.
of tears with my statistics. I'm still searching for the book, Matt, that would help me in my quest to not think that I'm rubbish at maths, but to enjoy it. I have a firm belief, Matt, that you would have written a book like that.
Yeah, oh, what? Fantastic segue. Yeah, no, I wanted, because everyone talks about Pythagoras and trigonometry and what are those buttons for on the calculator. So I wanted to set the record straight on trigonometry. So I wrote a book called Love Triangle, which I'm very proud of.
Very good.
Thank you.
Really well played.
It came out the same week. So the paperback's just come out. The hardback came out the same week as the House of Beckham expose, which was meant to be the #1 bestseller. Unbelievably, my book about trigonometry sold more copies.
Huge. Why am I the only one applauding?
I'm mentally applauding. I'm not.
Yeah.
You lazy sod.
That must have been a massive blow for Posh and Betts.
And their book had actual love triangles in it.
Which
so I,
allegedly so.
Really
allegedly.
Yeah.
But I was very pleased I could finally try to set the record straight on how wonderful. I mean, obviously I'm convinced, but I want more people.
So it's not just like a GCSE textbook.
No. It's
where you can solve stuff. Is there anything in there that you can solve? Like a little, I think of Myrtle. Have you heard of Myrtle? It's basically
like Wordle, but
no, it's like a murder mystery book that you can solve stuff. Basically,
yes.
Sudoku with pictures. No, well, it's not. Yeah, with whodunits. Not the point. The point is there anything you can like solve?
Yeah, I try to make it like a gateway book where the book you can just read it and you're like, oh, maths, stories about maths, how we've used maths. But I really want people to just be like, oh, that's interesting. Things like multiples of 9, the digits add to 9. Like, oh, maybe I'll look into that. So that's a lot of people just read it and put it away, but I want a few people just to go, you know what? Maybe I will look into a bit of mathematics.
On a very high note, I would like everyone's favourite number.
Oh,
Favourite number and a why.
okay. Who wants to kick us off? I think Matt Parker would be.
It would be pi. Love pi so much.
What do you mean? That's fucking loads of numbers. I thought
That's-
pi was infinity.
That's true. So before I said there are numbers you can't represent by cutting up sheep, pi is one of those numbers. It falls between the sheep.
You've gone full circle.
Yeah.
You've gone, oh my God.
Everyone likes a bookend.
Wow.
So I've tried to... So when you're cutting up sheep, you're basically getting fractions of a sheep.
And you're cutting up sheep. This little, this
From
cannot
earlier.
be clipped just on its own. When you're cutting up sheep, just
You were
cut up
talking
the
about how
sheep,
much you love slicing sheep up.
Yeah.
Sure.
So you always end up with a fraction of a sheep. Pi, as you say, has infinitely many digits. It's 3.14159, and that carries on. It never stops. But it is still between 3 and 4. It's between 3.1 and 3.2. Like, we know where it is. But it doesn't match any fraction. There's no fraction you can write down. Like 22 over 7 is close, and there are even closer ones. There is no fraction that equals pi. We call it a irrational number. It can never be pinned down to a fraction of a sheep.
I think I'd be pi.
You can't be pi. He's chosen pi.
I got pi.
You can't just copy Matt Parker.
All right. 7.
You didn't
Good-
say it
good
with any
choice.
conviction.
It is 7
People love 7.
Why'd you like 7?
because it's my birthday.
Oh.
But the irony is, I hate my birthday.
Mm.
But whenever I go on the roulette machine,
7.
I'll put £1 on red 7.
I'm going to go for 144.
Can I try and guess why you've gone for 144?
Yes, you can.
Is that the amount of shit songs the Beatles put out there?
How many chips and peas is 144?
That's 14 chips and 4 peas.
Yes, correct.
Sorry.
But it could be other things as well, though, couldn't it? Because if you really like peas, by your calculations, you max out at 9 peas. Could you remove some of your chips, remove 2 chips and substitute in for 20 peas, just to make your plate a more nutritious one?
Why is your number 144?
Because when we do times tables, it's the end. It's the maximum.
Yeah.
No one learns the 13 times table, do they? So it feels like the end. You get to 144, you're done. You completed the times table.
I do 20 times 20. 400.
Pick yourself up.
Just,
Why are you showing off about that in front of Matt?
just saying, Matt, like,
He's
look
right.
look how quickly I did that. 25 times 25. All right. Matt. Matt, I can't wait to go to the moon with you. You've been one of my favourite guests ever.
That's very kind of you.
I now want to add you
Well, what up?
to the growing list of guests that have left a positive impact on the show. Brackets. A plus B, close brackets, equals C. And C, in this example, is great guest.
It's been an honor to add to the sum total of the show.
He did
it better. He did it way better. Okay. Well, before you go, if you had to solve the Riemann hypotheses or win the lottery,
Yep.
which would you choose and why?
I would go the Riemann hypothesis. It's also would come with a big cash prize, but there's so much of maths because no one's solved it yet, but a lot of people have assumed it's true and done more maths based on that assumption.
What
It's
is
like
it? What is it?
It's a...
You don't know what it is?
No, I do. I just want to.
You know.
Matt will summarise it for us.
No, it's a question about the way that primes behave. We think they line up in a particular nice pattern, and all the ones we've checked do, but we don't know for certain if that will carry on for every single prime number.
And my follow-up question to that would be, what do prime numbers and prime colours have in common?
You can split a more complicated situation into smaller parts that build it up.
I think the second question was easier than the first.
Cheers, Matt.
My pleasure.